Hi everybody, so this is part one of a two-part midterm review. So the first part will be about number theory, the second part will be about graph theory. So before we get started, I wanted to remind you that I posted along with this review the midterm formula sheet, which you can either print if you're going to use ProctorU and they know that you're allowed to have it and they will want to look at it. You can't write anything else on it before the test starts, but you can have it, or if you come to campus, I will have them for you. But let me quickly show you that this is what it looks like. So it has the grid at the top with the numbers 1 through 100, so you can go through and mark and find the primes. That might be helpful when we're doing prime factorization and the Goldbach conjecture and stuff. And then it has the 4 formulas for doing sequences, so you might want to go ahead and print this before you get started looking at the answers. My idea for this video of the review is that you have already tried the review and you're just coming here to reference ones that you had some questions about. So it doesn't really do any good just to watch me do the review. You really need to do the review on your own to see what you got right, what you got wrong, and then that should help you out. So I will post just the answers so you could just look at them, and then you could kind of come in here and watch the parts that you need to get some extra help. So let's go ahead and get started. We're going to start with number 1, which just simply ask which of these are prime and select all that are correct so there is more than one answer. So looking at it, hopefully you know that 3 is prime, 18 is not because I know 2 goes into it, 29 is prime, 39 is not, I know 3 goes into it. Important on the test that if there's one that you're like kind of jumping at, slow yourself down. 51, I think you want to jump and say it's prime, but it's not. Remember those simple rules we had, like if it ends in an even, then you can divide by 2? Well, there's also a rule for 3s that if I can add the digits together and 3 goes into that number, then it's divisible by 3. So 5 plus 1 is 6, and 3 goes into 6, which means 51 is not prime. 82 divisible by 2, and 93, same thing again. 9 plus 3 is 12, 3 goes into 12, so 3 goes into 93. So here I have just 2 prime numbers. Another caution for you, 2 is the only even number that's a prime. So just because 2 is even doesn't make it not prime. So if I were to give you 2, 2 would be prime. 1 is not prime, neither is it composite. So 1 you don't want to circle as prime either. So just if I gave you some simple numbers to know what's prime, what's not. All right. So now we're going to use prime factorization. So we're going to start with number 75, and hopefully you know I do this upside down division. So it says you have to factor by primes, but it doesn't say what you have to start with. So I choose to start with 5 because I can clearly see 5 goes into 75. I highly encourage you to use your calculators and bring them with you to the test, or have it with you when you're using ProctorU. So 5 goes into 75, I would get 15, which says do 5 again, which gives me 3. All right, I can stop because I have all primes. So now this says 3 times 5 squared is my prime factorization. 164, this one I want to start with a 2, which gives me 82. So I want to do 2 again, which gives me 41. If you quickly looked at your little sheet, if you put together your primes, you would see that 41 is prime, so my answer would be 2 squared times 41. So I am doing powers when I do have the same factor more than once. 4,280, a much bigger number, but I still do the same thing. So I divide by 2, I get 2,140. So I divide by 2, I get 1,070. I divide by 2, I get 535. And this is, if you're going, how is she doing this so fast? Put in your calculator. Nobody's trying to say you have to know all these multiples. You just do division. So I know I'm done with my 2's, and I can see 535. 5 would go into it. You get 107. Now, if you get to 107, you're like, that's bigger than 100, what do I do? The answer is you take the square root of 107. Because what we said is if there's a factor of a number, then it's going to show up by the time you get to the square root of the number. So I need to look at the square root of 107, which is just a little bit bigger than 10. So I'll tell you what it is. Square root of 107 is 10.34. I just think 10. You just need to check all the primes less than 107. If none of those numbers go into 107, then I can tell you that 107 is prime. So what are the primes less than 10? 2, 3, 5, and 7. 2 clearly doesn't go into 107. 5 clearly doesn't go into 107. To check 3, I add 1, 0, and 7, which gives me 8, so 3 doesn't go in. So the only number you really need to check is 7, and you can check that in your calculator. You can put 7 in, you're going to see it doesn't come out to a whole number, so I can see 7 doesn't work also. So that tells me that 107 is prime, so my answer is 2 cubed times 5 times 107. So there's my prime factorization. All right, so let's move on up. And hopefully you see this is the same review. I just gave myself more space, so I had some space to write out stuff for you. All right, now I have to do all factors of these three numbers. So I have 84, 250, and 372. A couple things I want to tell you here. Number one is I'm going to write them in pairs because it helps me out. I also sometimes find it helpful to think like, how many primes are there, or how many factors are there for a number? So if you wanted, you could do the prime factorization. Even though I didn't ask for it, sometimes it's still helpful to go ahead and do it. So 2 goes into 84, I get 2 times. I divide by 2, which gives me 21, which I know is 3 and 7. So this says, and I'm going to write up here because I know I'm going to run out of room. Oops, that's supposed to be a 7. Sorry about that. I have 2 squared times 3 times 7. Okay. What I'm going to do is take each of the exponents and add 1. So 2 plus 1 is 3, 1 plus 1 is 2, 1 plus 1 is 2. And I'm going to multiply 3 times 2, which is 12. This is the number of factors of 84. Okay. So when I write them out, I know I'm looking for 12. When I get 12 factors, then I'm done. So I know 1 and 84 are factors. So there's 2 of them already. That's a 84. Sorry about that. 2, I know is 42. 3, and how do I know 3 goes in? Because 8 plus 4 is 12. 3 gives me 28. 4 gives me 21. Not 5, but 2 and 3 tells me 6 goes in, so 84 divided by 6 gives me 14. Okay, right now I can say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it says there's something else, and that something else should be, look, we did 2 and 3 is 6, well 3 and 4 is 12. So 84 divided by 12 is going to give me 7. So here, these are my 12 factors of 84. All right. So the same thing I can kind of go up here and do for 250 and say 2 goes into 250 125 times. And then let's divide that by 5, which gives me 25, which is 5 times 5. So this time I have 2 times 5 cubed. Okay. So again, that exponent, 1 plus 1 is 2, 3 plus 1 is 4. This says 2 times 4 is 8, so I'm going to find 8 factors. So the first 2 are easy. It's 1 and 250. Second 2 are also pretty easy, 2 and 125. Okay, definitely 5 goes in, and that would be 50 times. 10 would also go in, and that would give me 25. Now, it was kind of easy that time to just list them off, but now if we look at it, that's 2, 4, 6, 8, and I'm done. So there's no question of do I keep going. So I like this little trick about looking at the exponents. So let's try it again. Let's look at the 372, and I'm going to divide by 2. It gives me 186, which definitely says divide by 2 again. Okay, that gave me 93, which makes me think, let's try 3. Okay, now I have 31. All right, so now I'm done. 31 is prime. So I have 2 squared times 3 times 31. Again, the trick is in the exponents. So 2 plus 1, 3. 1 plus 1, 2. 1 plus 1, 2. So 3 times 2 times 2, this is 12. So I'm going to have 12 numbers as factors. So the first 2, again, really easy. 1 and 372. 2 gives me 186. We know 3 goes in because it was one of my factors. So 372 divided by 3 was 124. Let's try 4. It gives me 93. Okay. Now these first ones are pretty easy because I could see the 2 in my prime factorization. I can see the 3 in the prime factorization. 2 squared is 4 was in my prime factorization. I know 5 isn't there, but 2 and 3 being there tells me 6 is. So 372 divided by 6, which gives me 62. And just like before, when I did 2 and 3 is 6 and 3 and 4 is 12, so I'm just going to go ahead and jump to 12 and say 372 divided by 12, and it gives me 31. Now let's go ahead and count. I know I'm supposed to get 12 factors altogether, so this is 2, 4, 6, 8, 10, 12. I kind of wrote them kind of funny, but this is 2, 4, 6, 8, 10, 12. Sorry about that. For the next set, I said determine if it's abundant, perfect, or deficient. So I am building these in order. There is this closeness to the last one, where the last one said write all the factors. When I get to abundant, perfect, deficient, I want to write the proper factors, so I'm not going to include the number itself. So like when I start with the number 17, the only factor is 1 that's proper, right? I can't put 17 itself. That doesn't work, so don't include the number. So since 1 is the only number I get and 1 is less than 17, I know this is deficient. Okay. For 36, I have more. So I have 1, I have 2, I have 3, I have 4, I have 6, right? So I'm starting to list numbers that I know go into 36. I know 9 goes in, and that's kind of going 4 times 9 is 36. With 6 times 6 is 36. Do not write the 6 twice, write it once. 6 is one number, not 2. 3 goes into 36 12 times, 2 goes in 18 times, and you remember we don't write 36 itself. So I'm going to add in my calculator. 1 plus 2 plus 3 plus 4 plus 6 plus 9 plus 12 plus 18. That gave me 55. Okay, that's definitely abundant. You don't really have to know the exact number that it adds up to. If you can see like 12 and 18 is already 30, so definitely this is abundant, then write that. It's going to be multiple choice on that part. You're just going to pick it's deficient, abundant, or perfect. For 35, I know I have factors of 1, I have 5, I have 7. Definitely I can see that that is not even close to 35, so this is deficient. For 42, I have 1, I have 2, I have 3, not 4, not 5, I definitely have 6, I have 7. Alright, so I started just going in order, 1, 2, 3, 6, 7, but at some point you probably have to work backwards and say, how many times does that go in? So 6 and 7 were easy, but if you needed to do 42 divided by 3, that gives me 14, and then 42 divided by 2 is 21. So let's add that up, 1, 2, 3, 6, 7, 14, and 21. I got 54, which says abundant. Okay. And then this last one, 28. I have 1, I have 2, I have 4, I have 7. Then you have to think 4 times 7 is 28. 2 goes into 28 14 times. So let's add 1 plus 2 plus 4 plus 7 plus 14. This is 28. Remember when it equals what the number was? Then we call that perfect. All right, on number 5, express the number as the sum of two primes. So this is what I called in the videos the Goldbach conjecture, but I don't expect you to remember that word. So it will just say express the sum of two primes. There are multiple ways to do it. So if I were to give you, and I'm pretty sure I did make it multiple choice on the test, just pay attention that it fits, that the numbers are prime. Remember 1 is not prime, so do not use 1 as you're doing it. When I look at 26, the first thing that pops at me is 13 plus 13. Right? If when I divide by 2 I get 13, 13 is a prime, so I could write it twice. You could also do 3 plus 23. Let me see if there's any more. I could do 6 plus 19. So again, if I'm giving you multiple choice, which I am, you're just looking to make sure the numbers that I gave you in the sums are prime. And look, I just wrote the wrong number. This is supposed to be a 7, because 7 is prime. Let me see if my eraser will work. There we go. That's better. 7 plus 19 is 26. I think I saw the 6, so I wrote the 6. I think that's as far as I need to go on that one anyway. Okay, so 42. So I just kind of start going through numbers and see what I get. So like 5 plus 37 works. I could do 11 plus 31. I can do 13 and 29. So maybe you guys can kind of see what I'm doing here. I just kind of start rolling through prime numbers and see if things work or not. So let's try this one, 19 and 23. Okay. All right, 94, it's bigger, but I still have that same idea that I just want to start subtracting. I just want to start, in my head what I do is I start subtracting prime, seeing what works. So like I know 1's not a prime, so I don't use it. 2 is not going to make any sense because that would give me another even number. If you tried -3, you get 91, and 91's not prime even though you kind of want it to be. It's not. But you could do, if I subtract 7 gives me 87, that doesn't work. 97 minus 5 though is 89, so 5 plus 89, that's okay. You could do 83 and 11. I'm just picking a couple numbers to look at what would work. Well, I gave you a couple. I gave you 2. That's probably fine. There could be more. I'm okay with that. I'm promising you this is a multiple choice question. So if you have something different, if they're primes, that's fine. But just know, look at the numbers and like look for those outliers. Like if I'm giving you, if you look at the numbers and like say I had in there 94 as 7 plus 87, you should go no because 87 is not prime. So just pay attention to that. Are all the choices given? Are they all prime numbers? All right. So this one says find all twin primes between the given numbers. So it might help, and let's switch over here. So this one said to go between 30 and 46. So here I am over at 30 and 46. And if you were looking like 31, I don't know if it's going to write on this page. I got to tell it to you. 31 is prime, but 33 is not, so it's not a twin prime. 35 is not prime. 37 is, but 39 is not. 41 is prime, so is 43, so there's a twin prime. 47 is prime, but 49 is not, so that doesn't work. So right now, let's go back and write the 41 and 43. And we're done. Okay. So the next set, I said 70 and 100. So let's go over to 70. And 71 is prime. So is 73. 75 is not. 77 is not. 79 is prime, but 81 is not. 83 is prime, but 85 is not. 87 is not prime. 89 is prime, and so is 91. 93 is not prime. 95 is not prime. 97 is prime, but 99 is not. So when I'm looking at twin primes, I have 71 and 73, and I have 79. Let's write that first. 71 and 73. And then my other set was 89 and 91. All right, now we've gotten to greatest common factor. So I'm going to have, or greatest common divisor, same thing, GCD and LCM. So let's start with my 9 and my 12. And I say, well, what's in common? 3, which gives me 3 and 4. All right, I can't go any farther, so remember GCD is just what's on the outside, so this is 3. Okay. 50 and 72. Again, I'm going to start with a 2. So this gives me 25 and it gives me 36. Now the only thing else that's going to go into 25 is 5, which is not going to go into 36, so again, one stop, I'm done, it's a 2. Bigger, I have 140 and I have 220. I can see they both end in a 0, so I'm just going to immediately start by dividing by 10. Now notice 10 is not prime, and that's absolutely fine because that's not part of GCD. You don't have to use primes. So I have 14 and 22, which says, oh, those are both divisible by 2, so I'm going to take that out. It gives me 7 and 11, I stop. Now I multiply 10 times 2, it gives me 20. And maybe you were quicker than me and you saw 20 went in from the beginning. Awesome, you could have done that in one step instead of the 2 I did. So now we're going to go on to the LCM, and it's going to look really similar. I'm going to do that division again. So I have 32 and 44, and again, I'm going to start by 2 because it just looks so like right in my face. So I get 16 and 22, which says, oh, we'll just do 2 again, which gives me 8 and 11. Now this time I'm going to multiply all of these numbers together. So 2 times 2 times 8 times 11 gives me 352. I always think GCDs are smaller, so look at that, 3, 2, and 20. LCMs get bigger, so already I'm at 352. So let's try 16 and 20. And this time I kind of go, oh, I see 4 goes in. But if you saw 2, perfect. 4 goes into 16 4 times, 4 goes into 25 times. Again, I'm done. So I'm going to multiply 4 times 4 times 5, which is 80. One more of those. I have 108 and I have 215. Okay. So immediately I see 2 doesn't go in. So I go, how about 3? So I add 1, 0, and 8, which gives me 9. I add 5, 1, and 2, which gives me 8. So that's not really helpful. So 3 is not going to go in. So let's just start skipping through some primes. 5 is not going to go in because I can see 108 ends in 8. So I go, what about 7? So I'm going to do 108 divided by 7. Doesn't work. So I don't worry about that. Now I'm going to kind of stop because remember when we're looking for factors, we only go up to the square root of the number. The square root of 108, again, just bigger than 10. So I've got to the point where nothing goes into them. The only thing they have in common is 1. That's perfectly okay. Do 1 times 108 times 215, and it gives you 23,220. You always have an answer. So if they have nothing in common, multiply the two numbers together. All right, here we are at mods. And I separated the mods into a couple of different sections to make sure that we cover them individually, so it's not too much at once. More problems are better. I'd rather give you a lot of problems worth 1 or 2 points than a couple problems worth 5 or 10. Your grade's easier to build that way. All right, so remember here, I'm looking for the remainder. So I'm going to divide by the number it says in the mod and then say what's left over. Now you can treat it as division or you can treat it as subtraction. It's up to you. So if you want to say 9 minus 4 is 5, and then go 5 minus 4 is 1, that works. Or you can say 4 goes into 9 2 times, that gives me 8, and I have 1 left over. Either way, do you see how I got a 1? So that's what's important. You can also think about what's a multiple of the number that's close to the number I gave you. So like with 4, I think, oh, a number close to 9 that's a multiple 4 is 8, and 9 minus 8 is 1. I say that because when I get to the next one, I'm looking at 17, and I'm thinking, what's a multiple of 3 close to 17? It's 15. 17 minus 15 is 2. Right? So in this one, the answer was 1, and this one, the answer is 2. Again, if you want to do division, 3 goes into 17 5 times. There's 15. You get 2. That's perfectly okay with me. It's whatever works for you. And let me try to separate these out so they don't get too confusing. Okay. So 25 mod 8, I'm thinking. So we can write it over here. 8 goes into 25 3 times, which gives me 24, and I have 1 left over. Or I was thinking 24 is a multiple of 8. 25 minus 24 is 1. When you get to negatives, you need to make them positive. You have to add a multiple of the mod. In this particular case, I can just add the mod. Negative 2 plus 3 is 1. It's kind of the only way to do this. There's not something else you can do like a division. On negative 18, if you add 5, you get negative 13. So add 5 again. You get negative 8. Add 5 again. You get negative 3. Add 5 again. You get 2. All right. If you want another way to think about it, you think of a multiple of the mod. So my mod is 5, and I'm thinking, what's a multiple of 5 close to 18, but bigger than 18? So a multiple of 5 close to 18, but bigger would be 20, and I would do 20 minus 18 is 2. All All right. As we go back to perform the modular arithmetic, it's the same kind of ideas. I have 8 plus 4 is 12. 12 mod 7, you could just do 12 minus 7 is 5. 2 minus 11 is negative 9 mod 4. If you add 4, it's still going to be negative, so I'm going to add 12. That way I get 3. 7 plus 9 is 16. 16 mod 4, well, 16 is a multiple of 4, so my mod is 0. This just means what would be my remainder. If I go 4 into 16 where I get 4, I get 0. That's what's left over. 23 plus 13, this is 36. So once again, I have that same thing where 36 is a multiple of 9, so it gives me 0. All right, then we have equations using mods. Now with equations using mods, it's important that this is not algebra. You need to make a chart. So here's my chart. I have my values of x, I have values of 4x plus 1, and then I need to use my mod. And this time my mod is 7. Okay, so 0, 1, 2, 3, 4, 5, and 6. Remember, go 1 less than the mod. So the mod is 7, I go to 6, I always start at 0. Plug the 0 in. 4 times 0 is 0, plus 1 is 1. 4 times 1 is 4, plus 1 is 5. 4 times 2 is 8, plus 1 is 9. 4 times 3 is 12, plus 1 is 13. 4 times 4 is 16, plus 1 is 17. 4 times 5 is 20, I add 1 is 21. 4 times 6 is 24, plus 1 is 25. Another way to see is that 4 shows me there's a difference of 4. 1 plus 4 is 5. 5 and 4 is 9. 9 and 4 is 13. 13 and 4 is 17. So you should see that pattern here. Definitely this is like a sequence. Mod 7. 1 is less than 7, so I leave 1 alone. 5 is less than 7, I leave 5 alone. 9 is bigger than 7, so I do 9 minus 7 is 2. Didn't really write there though, did it? 13 minus 7 is 6. With 17, now that's a lot bigger than 7, so I'm going to subtract 14 to get 3. 21's a multiple of 7, so I write 0. And with 25, I'm thinking 25 minus 21 is 4. Okay. Now you got to go back and go, what am I looking for? You're looking for 6, which says x is 3. Right. So I need to do the same thing again, but this time I'm doing 3x minus 2 mod 6. So let's see if I can kind of move this off and add a new one in. Okay. So I have 0, 1, 2, 3, 4, and 5. I do 3 times 0, which is 0, minus 2 is negative 2. 3 times 1 is 3, minus 2 is 1. 3 times 2 is 6, minus 2 is 4. 3 times 3 is 9, minus 2 is 7. 3 times 4 is 12, minus 2 is 10. 3 times 5 is 15, minus 2 is 13. Again, that 3, you can see negative 2 plus 3 is 1, 1 and 3 is 4, 4 and 3 is 7, 7 and 3 is 10, 10 and 3 is 13, so I see the pattern. Mod 6, 6 minus 2 is 4. I leave 1 alone. I leave 4 alone. 7 minus 6 is 1. 10 minus 6 is 4. 13 mod 6 is 1, because I was thinking 12. 13 minus 12 is 1. Alright, so what I have this time is multiple answers. See this 4 3 times, and 4 corresponds to these numbers on this side. So x is 0, 2, and 4. On number 12, I'm giving you some Fibonacci terms, and I want you to find the next term. So I gave you f of 18 was 2584, and I gave you f of 19 was 4181. So I'm going to add those together, 2584 plus 6765. So I said all of that wrong. I have it in my calculator looking at it, so I just can't talk and write at the same time. Sorry about that. Let's fix it. There we go. 2584 plus 4181 is 6765. Now it's right. All right, f of 12 was 144. F of 13 was 233. You add that together, that's 377. So hopefully Fibonacci is easy. Just add them together, get the next one. All right, so now we're really into our sequences. So for number 13, I gave you 5 sequences, and I'm asking 2 questions. First, is it arithmetic or geometric? And then I want you to tell me 3 more terms. So when I look at the first one, I have 7, I have 12, I have 17. Luckily, when I look at it, I can see 12 is not a multiple of 7, so there's a pretty big clue that this is arithmetic. And I can see I added 5, and then 12 and 5 would be 17. So that one's kind of easy, arithmetic. In the next 3 terms, I just need to add 5 some more. So 5 and 17 is 22, 5 and 22 is 27, 27 and 5 is 32. It's kind of an ugly 32, but it works. Okay, then the next one, I have 2, 4, 6. Important, pay attention to, am I adding 2 or am I multiplying by 2? At first it's hard to tell until I get to that 4 and 6 where I can see I am adding, so this is arithmetic as well. So the next 3 would be 8, 10, and then 12. Right. On C, 3, 6, 12. Okay, am I adding 3 or am I multiplying by 2? And that 12 tells me I'm multiplying by 2, so this one is geometric. So adding is arithmetic, multiplying is geometric. So multiply by 2 again, 24, by 2 again, 48, by 2 again, 96. D, I have 100, I have 90, I have 80. So the numbers are getting smaller, but they're getting smaller by 10, so this is arithmetic. I'm adding negative 10, so this should be 70, 60, 50. Right. And the last one, I have 5, 20, 80. So I can see these are getting significantly bigger. This is geometric, and it looks like I'm multiplying by 4. So this one, 5, 20, 80, 80, and I'm just going to write them underneath because I don't have as much room there. So 80 times 4 is 320. Times 4 again is 1,280, and then times 4 one more time is 5,120. And then in this next one, number 14, it says find the first 4 terms in each sequence. So it doesn't matter if you state if they're geometric or arithmetic, it just matters that you plug in 1, 2, 3, and 4 and find the first 4 terms. So if I were to plug in 1, I would have 4 times 1 plus 6, which would be 10. If I plug in 2, I have 4 times 2 plus 6. So this is 8 plus 6 is 14. A3, I have 4 times 3 plus 6, so this is 12 plus 6 is 18. And then A4 is 4 times 4 plus 6, which is 22. If you can just see that they're increasing by 4, I went 10, 14, 18, 22, maybe that helps. On the test, you will be filling in the blank kind of things. This will be on Canvas. You should be kind of familiar with what this looks like from the different quizzes I've given you on there, so you'll just be filling in those things. So you won't write it like this, you'll just type it in. All right, so for letter B, B1 is 3 times 2 to the 1, which is 6. B2 is 3 times 2 squared, so 4 times 3 is 12. B3 is 3 times 2 cubed. This is 24, or sorry, 8 times 3 is 24. I'm telling you the answer. B4, 3 times 2 to the 4th. 2 to the 4th is 16. 16 times 3 is 48. Let me write some lines so you can see between there. For C, C1 is 5 to the 1 minus 1. This is 5 to the 0, which is 1. C2, 5, 2 minus 1 is just 5. C3, this is 3 minus 1, so that's 5 squared, which is 25. And then last one, C4, is 5 to the 4 minus 1, which is 5 cubed, which is 125. All right, then D. So I'm going to throw in 1. I have 7 times 1 minus 2 is 5. D2, 7 times 2 minus 2. 14 minus 2 is 12. D3 is 7 times 3 minus 2, which is 19. And then D4, I have 7 times 4 minus 2, which is 26. Alright, now when we get into these 15, 16, 17, 18, you may need to go back and reference the midterm formulas to make sure you have it out. So it says find A32 given A1 is 3 and D is 4. So I'm using the formula A sub n. So here's A sub 32 is the first term plus n minus 1. So this is 32 minus 1 times my difference of 4. So this is 3 plus 31 times 4. I got 127. Okay. Same thing here. I'm using the same formula. I'm looking at A sub n is equal to first term 16, and then I do 55 minus 1 times my difference of 7. So I have 16 plus 54 times 7. I get 394. Great, so those two are the arithmetic, but if you look at the formulas and let's switch over to them, do you notice it doesn't tell you which ones they are, but what's supposed to be your clue is there's a D here, so D is the arithmetic and D is the one I should grab. So I'm trying to find an A and I'm trying to see which one does it belong to. Well, with the D, I would use this formula. Now the next two are going to use this formula, A1 r to the n minus 1. So this one says, let's find A of 15, given my first term is 6, and then my ratio is 3, to the 15 minus 1. These numbers get really big really fast. I do try to control them a little, but they are bigger, so I'm not asking for the 55th term when I get to geometric because you'll see how big it is. So this is, I put in my calculator 6 times 3 to the 14th. I did not tell my calculator 15 minus 1. That will generally mess people up. Easier, just put in 15 minus 1 is 14. So I got 2, 8, 6, 9, 7, 8, 1, 4. Okay, really big number. Same thing with the next one. The ratio tells me that this is geometric, so if I want the 18th term, I use 1/4, then my ratio 2, and then to this 18 minus 1. It doesn't matter if you write parentheses or not, I just happen to this time. I'm going to put in my calculator 1/4 of 2 to the 17th. I don't like to mess with that 18 minus 1. I put in the 1/4 not because I know students hate fractions, but to kind of control this number and keep it from being so large, because geometric does grow really fast. So when I put in 1/4 2 to the 17th, I got 32,768. Okay. On number 19, I want you to write an expression for the term. So first thing I'm going to do on A is look at 4, 10, 16 and go, what's happening? Am I adding or am I multiplying? And to me it looks like we're adding 6. So this says I have a difference of 6. So the general term, AN, would be the first term, 4, plus n minus 1 times the difference of 6. So I'm doing exactly what the formula says. It says take the first term. That was 4. Put in n minus 1. You're not supposed to know what n is. That's why it's a general formula. We're going to multiply this out. So I have 4 plus 6n minus 6. So I distributed the 6, and I'm just going to simplify 6n minus 2. All right. You should try to check your answers. So notice if I put in 1 here, 6 times 1 is 6, minus 2 is 4. That's my first term. 6 times 2 is 12. 12 minus 2 is 10. That says, oh, we did a good job, and that's the answer we're supposed to get. All right, let's look at the next one. It went 3, 12, 48. That is not growing equally. It's growing quickly. So it says this is geometric, and the ratio here is 4. So my formula is A1. It's A sub n equals A1. So there's 3 times my ratio 4 to the n minus 1. You are finished. There's nothing else to do. You should want these geometric. Geometric is easier. So here's arithmetic where I had to do some simplifying, and here's geometric where I'm kind of one and done. Let's look at the next one. I went to 10, 50. Once again, I have a ratio. This time it's 5. So my A sub n is the first term, 2, times my ratio to the n minus 1, and we're finished. Alright, so the last one, I have 12, 15, 18. This one has a difference of 3. So to get my term, I'm going to take the first term, 12. I'm going to do n minus 1 times my difference of 3. This one will require me to simplify, so I have 3n minus 3. So here's 3n. 12 minus 3 is 9, so this is my answer. And again, remember we talked about checking. You can plug in 1. 3 and 9 gives me 12. I can put in 2. 6 and 9 gives me 15. 3, 9 and 9 gives me 18. So I do like that you can check it. That does make, it would make me feel better as a student, so I encourage you to do that. Alright, so here's the last two on this part. I'm pretty sure, yep, next part goes into graph theory. To find the sum. The word sum should really help you because you know when you flip over, the S's mean sum, the A's mean term. So this says sum. And on this sum, it says 4n minus 3. So you should be able to look at it at this point in the semester and say, is that arithmetic or geometric? There is no exponent, which means it's arithmetic, right? That's really important. So you can see number 21 is geometric. There's an exponent. So number 20 is arithmetic. So look at what it says that you need when you have an arithmetic. You need the first term, you need the last term, you need how many terms you need to divide by 2. So notice I don't have the first term, but I can find it. A1 is 4 times 1 minus, oops, did a bad job on my minus there. So here's minus 3. So 4 minus 3 just gives me 1. So there's my first term. Then I need to know my 50th term. So I do 4 times 50 minus 3. So, calculator, 4 times 50 minus 3 gives me 197. So my sum, S of 50, is my first term 1, my last term 197. The number of terms is 50, and I divide by 2. So I have 197 plus 1 is 198, and you may want to do it that way. Push equal, get 198 times 50, and then divide by 2. If you don't do that push equals, make sure you use parentheses. So my answer is 4,950. Alright, number 21, where we already talked about is geometric. So again, look at this sheet. It says I need the first term, then I need the ratio to the nth power over 1 minus r. So I don't need to know the last term. I just need to know the first term. So a1 will be 5 times 2 to the 1 minus 1. 1 minus 1 is 0, so 5 times 2 to the 0 is just 5. Anything to the 0 power is 1, except 0 to the 0, we don't do that, but any other number we would get 1. Alright, so now to get my S, again, really bad writing sometime with this stylus. So I'm trying to find S of 12. So I take my first term 5. My ratio is 2, so I have 1 minus 2. I put 12 here. This number should match this number over 1 minus my ratio. Even though, it's just the way we end up writing it, see how there weren't parentheses here? When you go to put them in the calculator, you need parentheses. Or you need to hit equals, or you need to do it in your head. You need to do something, but I'm going to put parentheses there. So now I have 5 times parentheses 1 minus 2 to the 12th. Then close parentheses divided by parentheses 1 minus 2. Now I get 20,475. Red flag should be if you do this and you get a negative answer, that shouldn't be possible because these terms were positive to begin with. And sometimes, like if you don't use your parentheses or something, maybe that could happen. So be careful with your parentheses. Be overly cautious. Write down steps if you need to. Alright, so that was the first half. Hopefully that went pretty well, and then you can come back later and check out the second half.